Okay, so Module 4, Lesson 2 has 4 different topics that we're going to be talking about. We have the fundamentals of probability, probability using permutations and combinations, events involving not or, and then we have odds. And the last part is events involving and then conditional probability. So we will be getting into some more intricate probabilities. We'll start off slow with just the basics, and then we'll go in deeper. So the fundamentals of probability, we have an experiment, which is any occurrence for which the outcome is uncertain. For instance, it could be a coin toss. We have a sample space, which is the set of all possible outcomes of an experiment. And then an event is any subset of a sample space. So let's say that we are tossing a coin. That is going to be our experiment. The sample space is going to be the possible outcomes of that coin toss. So we can either get heads or tails. And then the event, we have to pick a specific event. So let's say that we want heads. So if we were calculating the probability of flipping a heads, we can either get heads or tails. So we have 2 options, and heads is one of those 2 options. So we have a 50% chance of getting heads, which means we have 50% chance of getting tails. So the probability, this particular formula is what you want to look at. You're going to take the number of outcomes in that specific event and divide by the total number of possible outcomes. Now your probability is always going to be from 0 to 1. So if it's closer to 0, or if it is 0, it's probably not going to happen. Whenever it gets closer to 1, then it has a higher percent of happening. So let's look at our first exercise. Exercise 1 says that a dice is rolled. It says the set of equally likely outcomes is 1, 2, 3, 4, 5, and 6. So we have just a normal dice. We roll it. We can either get the numbers 1, 2, 3, 4, 5, or 6. So we are going to find the probability of rolling, and we have 5 different options. So we want, on A, we want the probability of rolling the number 4. So 6, we have 6 different numbers that we are choosing from, and we are going to pick 4 out of those 6 numbers. So remember, our probability of the event is the number of outcomes in that event divided by the total number of possible outcomes. So the event that we are looking at is the number 4. So the probability of getting a number 4 equals the number of outcomes. So we have the number of outcomes of a 4 divided by the total number of outcomes. So our total number of outcomes is going to be 6, because we have 6 numbers that we can roll from that dice. There's only one 4. So our probability would be 1 over 6, or 1 out of 6. Okay, on B, we want the probability of rolling an odd number. So let's look at our sample space, or our outcomes. We have 1, 2, 3, 4, 5, and 6. Out of those numbers, we have 1, 3, and 5 that are odd. So we have 3 odd numbers divided by our 6 total numbers to choose from. So 3 over 6 reduces down to 1 over 2. All right, on C, we want to roll a number less than 3. So the probability of numbers less than 3. So let's look at our outcomes. Out of the numbers 1, 2, 3, 4, 5, and 6, only 1 and 2 are less than 3. So we have 1 and 2, so we have 2 numbers that are less than 3 divided by our 6 total numbers. And that reduces to 1/3. Okay. A number less than 8. All right, so all of our numbers are less than 8. 1, 2, 3, 4, 5, and 6. So that means we have 6 out of 6, which is 1, or 100%. And then a number greater than 8. So probability of a number greater than 8 is 0, because there are no numbers that are greater than 8 on our dice. All right, number 2. You are dealt 1 card from a standard 52 deck card. Find the probability of being dealt. So in order to do these, it is very helpful that you know what a deck of cards, what all is in a deck of cards. So I'm going to pull this up. You make it bigger. Uh-oh. Okay, so these are all of the cards in a deck of cards. As you can see, we have 4 different suits. We have clubs, hearts, spades, and diamonds. And then each suit has the same cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have jack, queen, and king. So we want to find the probability of being dealt. On the first one, we're looking for a queen. So remember, a probability of an event equals the number of outcomes in that event divided by our total number of outcomes. So in this one, we are looking for a queen. So we need to find the total number of queens in our deck of cards and then divide that by the total number of cards in our deck of cards. So it tells us that there's 52 cards. If you didn't know, there's 52 cards in a deck. So that means that that's going to be our denominator in all of these questions. So we really just need to find the number of outcomes in each specific event. So if you look at your picture, if you need to use your picture, that is fine. There are 4 of each different number, each different jack, queen, king. So we have 4 queens in our deck of cards. So we have 4 out of 52 cards. And we want to reduce this down, which reduces down to 1 out of 13. All right, on the second one, we are looking for the probability of being dealt a club. So the probability of getting a club. So like I was saying, there are 4 different suits. So the club is the suit. It's this top one right here. And you can go through and count, but there are 13 cards for each different suit. So we have a total of 13 cards that are clubs. So 13 and then 52 for our total number of cards. And this reduces down to 1/4. And that makes sense because the clubs are 1 out of the 4 suits. A picture card or a face card. So if you look at our face cards, it is the Jack, Queen, and King for each different suit. So we have 12 of those face cards. So the probability of a face card is 12 out of 52, which reduces down to 3/13. And then the last one is the Ace of Clubs. So they are very specific. Not only is it a clubs, but they want the Ace of Clubs. So if you look, there's only one of those cards. So the probability of getting the Ace of Clubs, we just have that one card out of the 52. Okay. The next question, we are using this table. So it says the number of people in the United States living alone in millions. So we have it broken up between the ages of 15 to 24, 25 to 34, and so on up into over 75. And then it's also broken down by male, female, and then both together. And so they have the totals of each column and each row, and then at the end, this 29.3, that's going to be the total of everybody that they looked at. So it says use the table above, find the probability expressed as a decimal rounded to the nearest hundred that a randomly selected American living alone is a male. So they don't give any specific age, they just tell us male. So we want to use the total of the men, which would be 12.5. So probability of a male is going to be the number of male living alone divided by the total number of people. So the 29.3, this is going to be our denominator for every single problem because this is our total number. So we do the number of males, which is 12.5, divided by 29.3. You can put this in your calculator and you should get 0.426, which rounds to 0.43 because they want rounded to the nearest hundredth, which is 2 decimal places. Okay, on B, we want the 25 to 34 age group. So 25 to 34. They do not specify if they want male or female, so we're going to look at the total for that age group, which would be 3.8. And like I said, we are going to use that same total number of outcomes, which is 29.3. When you divide that out, you should get 0.129, which reduces to 0.1, or which rounds to 0.13. Okay, and then the last one is a woman in the 15 to 24 age range. So we're looking for a woman and we want the 15 to 24 age range. So we're going to go to our table. The 15 to 24 age range is this first column and we want the females. So 0.8 out of the 29.3. Divide that and you should get 0.027, which rounds to 0.03. Okay, so this was just our basic probability. Now we are going to look at probabilities with permutations and combinations. So remember, a permutation is where order matters, and then a combination, order does not matter. So a permutation, order matters, and then a combination, order does not matter. Okay, so it says a group consists of 4 men and 5 women, and then 3 people are selected to attend a conference. And then it gives us 3 different outcomes. So remember, we're going to use the probability of a specific event equals the number of outcomes in our event divided by the total number of outcomes. Alright, so remember the permutation, we used the NPR formula, and then the combination we used NCR. So we are going to use those again here. So part A says, in how many ways can 3 people be selected from this group of 9? So it's just asking for 3 people. It doesn't specify men or women. So we are going to use a combination because order does not matter. And we have 9 total people. So order does not matter, so it is a combination. So we'll use NCR. And remember, your bigger number always comes first. We have 9 people and we are choosing 3. So NCR, when you plug that in, you should get 84. So that is the answer for this question. We're not calculating the probability until part C. So part B says, in how many ways can 3 women be selected from the 5 women? So we're still using a combination. We're still using NCR. But this time we are only looking at the women. So we have 5 total women and we are choosing 3 of them. So we'll do 5C3 in the calculator and you should get 10. Okay, now it says find the probability that the selected group will consist of all women. So what we've been doing is we have been getting our numbers for our fraction for part C. So we want the probability of all 3 women being selected. So we want the number of women for that event divided by our total number of outcomes. So our total number of outcomes, we are going to use our answer from part A because we have 9 total people and we are choosing 3. And then the women, we want all 3 of those women. So we have 5 total women and we are choosing 3 of them. So this is how you would set up this probability. And so it would be 10 over 84, which reduces down to 5 over 42. So let me show you how you want to do this in your calculator. Let me make this a little bit smaller. So remember, you're going to click math and then you're going to use your arrow and scroll over to probability, and then we can scroll down and we can select NCR. So we have our first NCR, which is going to be 5C3. This is for the 5 women and we want to choose 3 of those. Okay, and then now I'm going to divide that by our other piece. So go over to probability, NCR, and we have 9C3. and it'll give it, if you do it this way, it'll give it as a decimal. If you click on math and right here where it's fraction, just hit enter, it'll take your answer and turn it into a fraction, and it'll give you 5/42. So this is how we're going to be doing a lot of our probability questions. All right, number 2. A player wins the jackpot by matching all 5 numbers drawn from the white balls, 1 through 56, and matching the number on the gold mega ball. So this is kind of like the Powerball lottery that we know. And it says, what is the probability of winning the jackpot? So you know, whenever you play a lottery, there's only one ticket that is right. So you have to get all of the matching numbers, the 5 numbers, and you have to get the gold mega ball. It sounds easier than it really is. So if we were to look at all of the possible outcomes or all of the possible combinations for our lottery, this is what it would look like. So numbers 1, 2, 3, 4, 5, 1, 2, 3, 4, 6. And so this just shows all of the different variations for each ticket that can be bought. And so it goes on and on and on and on and on and on all the way. And then this is only showing numbers 1 through 39. So in order to win the lotto, you have to pick that one ticket that matches all of the numbers. So there's only one way for you to win the lottery. So we're going to find the probability of winning this jackpot. So the what we just looked at only shows the matching the first 5 numbers. It doesn't show also getting the mega ball. So what we're going to do is we're going to take the combo of the white and multiply it by the gold. So it is a combination, so we're using the NCR formula. And we, like I said, we're going to multiply. So for the white balls, we have 56 total numbers, and we want to match 5 of those. So we have 56, and we are choosing those 5 numbers. For the gold balls, we have 46, and we are only choosing 1. So we are going to multiply these together. This is going to be our total number of outcomes for this lottery. So when we set up our probability, the probability of winning, like I said, there's always going to be that one winner. You only have one way to get that ticket. But if you are confused at how we get one, I can show you. So we have to choose from those 5 numbers. So let me go to math, probability, and do our NCR. So we have 5 numbers that get picked that are winners, and we want to choose all 5 of those. If we hit enter, it's 1, because there's only one way for that to happen. Same thing for the gold balls. We have 1 and we're choosing 1, and there's only one way for that to happen. So 1 is going to be our numerator. Whenever you're doing the denominator, you can multiply them together. So we have 56, and we're choosing 5. And then we multiply that by 46, and we're choosing 1. So our probability would be 1 over this number, which would be 175,711,536. And that is your answer. So it is a very, very small probability, but I mean, people do win these things. All right, number 3. A box contains 25 transistors. 6 of them are defective. If 6 A box contains 25 transistors. 6 of them are defective. If 6 are selected at random, find the probability that all are defective or none are defective. So we have 25 total transistors, and we have 6 that are bad. So if 6 of them are bad, then that means 19 of them are good. So the first probability, we want to find that all of them are defective. We want all 6 bad transistors. So we want to select all 6 of these transistors that are defective. So we have 6 that we're choosing from. This is a combination because it doesn't matter if it is selected first or last, it still gets chosen. So we have 6, and we want to choose all 6 of those that are bad. That is the number of outcomes for our event. Our total number of outcomes, we have 25 total transistors, and we're choosing 6 of them. Okay, we can put this into our calculator. It's not letting me do it as a fraction, so let me just do math, probability, NCR, and I'll do 25 C6. And this is our denominator. We know that our numerator is 1, so it is 1 over 177, 100. Okay, so that is choosing all 6 that are defective. If we want none that are defective, we want 6 of the 19 that are good. Okay, so very similar. Our denominator is staying the same. We have 25 and we're choosing 6. For our specific event, we have 19 that are good and we are choosing 6 of those. So let me do these separately. Math, probability, NCR, we have 19 and we're choosing 6. And then we already have our denominator of 177, 100. So let's see, 27,132 divided by 177, 100. Reduces down to 969 over 6325. Okay, so we have 27,132 divided by 177, 100. And that goes down to 969 over 6325. So you can do it like this. And just read the directions of Pearson. They might want it as a fraction, or they might want it as a decimal. If it's a decimal, then it'll be 0.1532. Alright, number 4. If you are dealt 4 cards from a shuffled deck of 52 cards, find the probability of getting 2 queens and 2 kings. So we're picking 4 cards from our deck of 52 cards. We want to draw 2 queens and 2 kings. So anytime that we have 2 things that we are looking for, we're going to multiply them. We're going to use that fundamental counting principle. So we're going to take the 2 queens, multiply it by the 2 kings. So it is still a combination that we're looking at, because it doesn't matter if that card is selected first or if it's fourth. As long as the queens and kings are selected, the order doesn't matter. So the event that we're looking at for the queens, we have 4 total queens that we can choose from in our deck. We want to choose 2 of those. So it would be 4C2. Same thing for the kings. We have 4 kings and we are choosing 2 of them. So 4C2. Now, this is what is in our numerator. We're going to multiply these 2 together. Our denominator is going to be our total number of outcomes. So we have 52 total cards and we are choosing 4 cards total. So we can set this up in our calculator. Okay, so let me put this into the calculator. So we have 4C2 times 4C2. So we have 36 in our numerator. And I'm doing it separately because these calculators, we have to change the settings. Oops, 52C4. In order for you to do it all at once, you'd have to change the settings, and I'm not going to get into all that right now. So we have 36 over 270, 725. So let's see if it can be reduced. 5. Math. Okay, so we'll leave it as 36 over 270,725.